right. So whether you're morning time and just waking up, I hope that intro reel really, got your gears going. We're so excited to have Nakita Reed with us today. She's going to be sharing a presentation about a retrofit and the first Passive House certified building in Baltimore. So yay for East Coast, driving the wave of the Passive House movement. And Zoe's going to give you a little more of an intro about Nakita.
Thanks, Carmel. Yeah, we have a lot of East Coasters, so y'all are representing well. Yeah, very excited to be introducing Nakita. Nakita Reed is an award-winning architect and preservationist, a CPHC and sustainability advocate, public speaker and podcast host as well as a senior advocate or senior associate at Quinn Evans Architects. And she enjoys blending preservation, sustainability, and perspectives of diversity, equity, and inclusion into her projects. So thank you so much, Nakita, for joining us today, and please take it away.
We're going to go ahead and just jump right in, and we'll save some time for Q&As at the end, but feel free to ask questions in the chat as well. So a little bit about me. I am a licensed architect, a trained preservationist, and a credentialed sustainability professional. And for me, architecture and preservation have always gone together. I got into architecture because I wanted to work with existing buildings, and then going to school, realizing that, going through architecture school and wondering, why aren't we talking about existing buildings as much? So I went and did preservation and kind of really been focused on blending the two together. And one of the reasons why I really think that preservation is a great fit for sustainability is because it really is about reusing what we already have. And so the big takeaway I wanted to leave you with about me is that for me, it's both sustainable and historic, not one or the other. And so let's zoom out to the global scale. And so why existing buildings? I'm always surprised when I meet people who are wondering, well, what do existing buildings have to do with climate change? And it's like, oh, we're starting there. All right, that's a good baseline because it's everything. And so being able to talk to policymakers and developers and other designers to understand the impact of the existing buildings that has on climate action is something that I really enjoy doing. And so here are a couple different aerial views of different cities just to give you a sense of how much is there. And we really need to deal with both the tall buildings, the mountains, as Nazria calls them, and the carpet buildings, which are also the lower scale buildings. There's so much here for us to work with. Two quotes that I often think about are the greenest building is the one that's already built, which is credited to Carl Elefante, FAIA, who was one of he is one of Quinn Evans' principal emeritus. And so he was a big shaper of Quinn Evans' sustainability ethos when he was here. And the other one is that building reuse is climate action. And that's a shout out from Lori Ferris, who's one of the co-chairs of an organization I'll talk about coming up. So one of the reasons why it's super important for us to deal with the existing buildings that we have is because by 2040, 2/3 of the global building stock that's here today is still going to be here and exist. And so without upgrades to any of these buildings, they're still going to be emitting greenhouse gases. It's still going to be contributing to a lot of the climate change issues that we're having. And for those of you who don't know this, there's a great stat on the right that kind of shows how building operations and building materials impact greenhouse gas emissions and what that all looks like. I'm sure at this point I'm preaching to the choir, but wanted to make sure I put this in for some level setting just in case there was anyone who was not thinking about existing buildings in this climate action situation. And so one of the things that I found going through my education and my career is that there have been a lot of silos. So a lot of times the preservation folks are only talking to preservation folks. Architects tend to only talk to architects, and the sustainability folks sometimes only talk to the sustainability folks, not realizing that we really need to be working together because we don't have time to duplicate efforts and not be in communication. And so one of the organizations that was founded in 2017 is the Zero Net Carbon Collaboration for Existing and Historic Buildings, also known as the ZNCC. We know it's not it doesn't roll off the tongue as well, but it's a great organization. And the organizations that are highlighted in purple are on the steering committee for ZNCC. And what we do is we really try to have conversations across silos, across industries to help see what's happening across the world, across the industry, so that we can make sure that we are being able to share best practices. And I'm one of the co-chairs of the organization with Lori Ferris, Scott Henson, and Charlie Crane. And it's been a really great way to be able to communicate across the industry to keep talking about what's going on. And so one of the things I wanted to also level set in this conversation is the fact that there are different types of existing buildings. The scale of preservation slides a little bit. And so an existing building is any building that is constructed and or has been occupied at some point, or perhaps it's just constructed and waiting there. A historic building, in this country at least, is typically any building that's at least 50 years old. That's typically the how old a building needs to be for it to be eligible to then be listed on the National Register of Historic Places. But a certified historic building is any building that is actually listed on any of the local, state, or national registers. And so you can have a historic building that's not a certified historic building. And I wanted to mention this because depending upon what kind of protection or preservation status and existing status of your building that you're starting with, that's going to impact what you can actually do to the building, as well as impact what sort of funding sources you can go after for the building and all that. So just wanted to level set in terms of what the different options are. And so the past and the future merge to meet us here. And this is a poignant Beyonce quote that I love, not only because I think she's great, but also because we really need to address the fact that we have so many trillions of existing square feet of built stock that we need to deal with. But we also need to work towards a net zero decarbonized future. And so we are not going to get there through demolition. We're not going to get there through getting rid of all of the buildings that we currently have. We must deal with and make improvements to the existing buildings that we currently have in our stock. So let's zoom into the building scale. So this is a project in Baltimore, Maryland, and it is pre-certified under Phius's 2018 program. And for those of you who were at PhiusCon this year, this may be familiar. This was presented by my colleague Dave Gavin and Jessica Albinetti, and so I'll have their contact information as well. But we wanted to represent it here as well to highlight projects that's happening in Baltimore. And so we use the word, or Dave and Justin use the word palimpsest, because it's really something that's reused, but still shows traces of its original form. And this is a really great principle that's true to the compound as well as the East Baltimore Midway community. And so the way that the team worked is that Quinn Evans served as the architect on the project as well as the CPHC. And then New Ecology did the co-documentation and all of the other affiliates, so it's Energy Star, Zero Net Ready, Indoor EPA Plus, and all of the other calculations and ratings that were needed. Dave is on the call, so if there are any technical questions that I can't quite answer since I wasn't on this project team, he will jump in and throw me a lifeline. So some quick facts about Quinn Evans, for those of you who don't know us. We've been in business for a while. We have 6 office locations. We're 52% women-owned. We have over 200 staff, and on staff we have 4 CPHCs so far. I know there are some other colleagues who are interested in getting the certification as well. We are known for our work with existing buildings and adaptive reuse projects, but we also are known for making sure that we are making deep energy retrofits in a lot of our existing historic projects. On this project, we were fortunate to work with a great client who had a fantastic community vision. And so I'll just read it real quick in case anyone's listening in and not looking at the screen. So modeling healthy, high-quality housing for our community and neighborhood is a major motivation for working with passive buildings. Many Baltimore artists and also many Midway residents don't have a lot of financial power, and our neighborhood is one that has been disinvested for decades. We wanted to append this trend and show that these two overlapping groups actually deserve the highest quality housing in terms of environmental health, functionality, and beauty. That's also affordable. And we hope that it's an example of what's possible in Baltimore. And this is from Nick, who is the head of the Midway Neighborhood Cooperative, who is actually the GC on the project and self-performing a lot of the work. And a lot of the impetus for this work was part of and inspired from the ghost ship tragedy that happened in California back in 2016. It was artist housing that unfortunately caught on fire, and there was a lot of loss of life. And this fire and this tragedy spurred a crackdown on zoning to make housing, particularly artist cooperative housing that kind of pops up unregulated, make it more regulated, affordable, and safe. Or rather make it more regulated and safe. But it did not address the fact that there's still a lack of naturally occurring affordable artist housing, and a lot of artist collectives are popping up for survival. And so our first interaction with this client was through working with them on another one of their properties to really do by updating their sprinklers and proper egress paths to make sure that people living in their cooperatives would also have safe access. And so when they decided that they needed to do another project, they came back to us, and that was a fantastic way to continue that relationship. And so a little bit of background on Baltimore. For those of you who don't know, Baltimore has had a steady decline for a number of decades, partly due to a lot of discriminatory lending, as well as just urban renewal and other things that a lot of other legacy cities are dealing with. We have had about a 33% population decline from its peak. And because of that, Baltimore has a lot of vacant housing stock, but we still have a shortage of affordable housing. But one of the great things about Baltimore is that a lot of our building stock is still here. It hasn't been demolished yet. And so optimistically, there'll be a lot more renovations happening so that these buildings can be rehabbed and not demolished. And so that the historic fabric can be maintained of the building and of the city. Baltimore is known for something called the White L and the Black Butterfly. And so the White L is this area kind of downtown to Inner Harbor, and then the Black Butterfly are the areas typically in East and West Baltimore. And a lot of that goes back to the redlining maps and where the mortgages and investments were allowed to be made and other systemic racist issues and that sort of thing. But all that to say, the client purposely has a project located in an area that has been disinvested. And based on their mission, they wanted to make sure that they were able to bring something to this community that was going to prove and show another way, another prototype for how to build. And so they had 4 underutilized historic row houses on their property. And these are historic, but not certified historic, just to point that out. But they did want to keep with their mission to reuse as much as possible and keep the neighborhood character intact. And so because of that, we needed to insulate on the interior. They also knew that they wanted to make it a high-performing building, and because they knew they were going to be long-term stakeholders in the community. And so this building is going out to Passive House, as I mentioned, and it's been interesting because of the different ways that things are classified. It's 4 row houses that are being combined into 2. And so one of the things that we had to work through as they were going through it was, it's considered 1 unit for one rating system, it's considered multiple for another. And so some of the co-regulation green rating certifications has been a challenge that New Ecology has been helping us through. Here's a diagram for high-level interventions of what's happening. And so basically the blue is the pre-existing shell of the historic building. The yellow is the new insulated shell, and then the red is the continuous air barrier. And so it was the desire to make sure that we were still providing all of the space and programming needed, but working within the constraints of the existing building. And due to the deteriorated structure, we knew we needed to maximize the number of rooms that were available to be affordable housing. And so we inserted a new structure inside of the existing shells and then created the addition above and behind the volume. And so this really is acting as a building within a building, and the new structure is providing the framework to apply the passive principles, as well as insulating the shell and the continuous air barrier. Here's a typical floor plan of the combined row houses. And so on the ground floor, there's a living room, 2 bedrooms, and a kitchen. The central stair is going around up to bedrooms and dens above. And it's mirrored on the other side, so there's 2 floor plans of these ones. And then the 3rd floor hosts a recording studio and a rear roof deck. And we have really simple, flexible interiors throughout this one. So since Quinn Evans served as both the architect and the CPHC, the design process was pretty seamless. We were able to focus on the challenges for the interior side of the masonry retrofit and identify many of the critical junctions. And so it's been great to really hear from Dave some of the issues that they went through, and also a lot of the ways that they worked with Phius to work through some of these. On the exterior of the existing masonry structures, they made sure to install a service cavity, which you can see in this detail here, really to protect the air barrier and to provide ways to, provide ways to improve the connection there. And then we also, go to the next one. We also worked with Phius a lot on this one. Here is kind of the screenshot of some of the supporting documentation and the back and forth of some of the modeling. And so I've been told that the first attempt to pre-certified was a little bit mixed, but there was a major focus on thermal bridging and hydrothermal analysis. And so New Ecology was able to work through a lot of the calculations with Dave, and they realized that the existing masonry walls, rather the thermal bridging calculations for the existing masonry walls, kind of performed as expected, and it wasn't as major of a hurdle as many people were expecting. But they did say that finding a retrofit assembly that was able to provide enough insulation and meet the heating and cooling commands and be durable and dry was a little bit challenging. And so they worked with Phius to act as a consultant and provide more of that hydrothermal modeling to come up with different solutions. And so a lot of that worked out being resolved. And so some of the highlights and some of the things that got refined through that process was the realization that they needed to also insulate on the party wall. So here's the exterior front wall, and then this is the party wall that existed between some of the units. But even though this was technically an interior wall, they still needed to insulate back of almost 4 feet to be able to minimize the thermal bridging from here, and then insulate on the inside of that wall. And then by working with Phius, they were able to determine a safe path forward using the modified version of the various retrofit assemblies so that they could make sure that the insulation was less moisture sensitive. And then one of the other highlights that also happened on the detailing was giving the contractor, particularly since the client was self-performing, giving them more details on kind of some of the process for what needs to happen. And so one of the detail items that I pulled out was this kind of step-by-step of wrapping the Intello plus smart vapor retire along the outside edge of the rim joist, then laying over the subfloor prior to setting the wall and sill plate, and then after the sill plate and wall was set up, then lift up and fasten to the wall stud. So sometimes providing a little bit more detail like that on the architecture side can help the contractors install things correctly. And there's a fine line between making sure we're not getting too much into ways and means, but also when it comes to passive projects, there has to be a little bit more detail and communication given to make sure that the contractor can construct it correctly. And so from there, the building was design certified and proceeded to the construction phase. And so there was, lots of the details, and we can get into some of this in the questions and answers, but just wanted to show some highlights of some of the information that was provided. Getting to some of the construction photos, there were a number of, working with existing buildings, there's always unforeseen conditions, and this one was no exception. And so one of the things that had to happen on the right-hand side, there had to be more lime plaster put on the existing rubble foundation because there needed to be a smoother finish to be able to apply the secondary air barrier. And so thinking through the construction process, thinking through making sure substrates are prepared correctly so that things can adhere the way they need to adhere was something that definitely came through a lot in the construction process. And then even making sure to, do lime plaster on party walls and thinking through how the air barrier is going to be impacted. Here's a photo of the construction of the new concrete underpinning at the basement, as well as the slab on grade for the rear additions that was happening. And then just seeing how the shell within a shell was being constructed. Here's a photo of the pop-up on the roof and kind of showing how it's set back a little bit from the cornice line. And then on the bottom right, bottom left, it's showing the air barrier on the party walls because there really was an attempt to try and compartmentalize each row house. And then being able to still complete the framing and work within the existing buildings. So one of the fun things about this project is that the exterior finished material also helps to serve as insulation. And so thermocork is the exterior material that's used on the pop-up portion and the rear of the building. And then the right side is the yellow drainage plane that's put on before the thermocork was actually installed. One of the sometimes frustrating things about working with an existing building, particularly when you're trying to pass your blow door test, is that sometimes it takes a little bit of chasing to find where the gaps in the air barrier are. And so for this one in particular, there seems to be much more issues with trying to get the detail behind the wood cornice airfield. And so there was additional insulation that was provided and additional detailing to be able to make this work so the blower door could actually be passed. Oh, there you go, a little video. And, oh, sorry, one second. And so here's a detail of the windows and that insulation, as well as the insulation in the walls. And so originally the design team wanted to use dense packed cellulose, but in working with Phius, they realized that actually using EPS and mineral wool would perform better and also dry better than if and when water got into the wall, that would dry better than dense packed cellulose. So that was one of the lessons learned when working with Phius. So back to air barrier and blower door. And so despite all the different detailing, air sealing, all the targets and things like that, they still did have to go back with aero barrier to be able to hit the targets needed to be able to make that work. And for reference, even though, okay, so the 4 buildings got combined into 2 row houses, but for the blower door test, they were 1 blower door. And so on the top right, what you're seeing, that's the connection between the units that actually makes all of the air ventilation and all that stuff work. Here are some finished photos of what it's looking like, at least, or partially finished. So some of the window details for the window trim. Inside the stairs, showing kind of the wood and all of the simple materials that are going to be used as a backdrop, so that this really can be a space for the artists to be able to let their creativity shine through. But it's also going to be a very well insulated and healthy place for them to live. And so we've got to talk about some of the accolades, of course. We are one of the first Phius pre-certified buildings in Baltimore, and also the first Phius pre-certified masonry retrofit in Maryland. And so the building is not occupied yet. It's almost done. They are now just getting done and down to the finishes, finishing the MEP installs and verification, and then they'll get their certificate of occupancy. That was a very high-level, quick view of the project. I know we had about 20 minutes, so thanks for listening. These are the contact information for me, David, and Justin, as well as links for you to find out more about the compound and the Midway Neighborhood Corporation if you are interested. Thank you so much. I'll open up for questions.
Thank you so much, Nakita. I personally appreciated that you didn't only show the nitty-gritty of the project and the how, but also the why, the background of what this building is serving, the greater context within the city. And that's always, I think, really impactful and inspirational. And you know, this is in so many ways a model to so many other folks that are trying to do similar things to our existing building stock up and down the East Coast and across the nation. I think we're going to do a very quick break for sponsors, and then we'll jump right into the questions because they're flowing in.
That's right.
Okay.
Thank you. And Nakita, that was amazing. Thank you so much for doing this and being here and sharing this amazing project. I want to just take a moment to thank the sponsors who make our work at Passive House Accelerator possible. So starting with our stakeholder partner, NYSERDA, our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Glavel, Minutair, Partel, Rockwell North America, Stillcorp, and Zola Windows. And thanks as well to our champion sponsors, Bewizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, Proseco, and Source 2050. And a big shout out to our patron sponsors as well, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Enotech Windows and Doors, Lamelux, Longboard, Owens Corning, RDH Building Science, and Sanderson Design. So a big thank you to the sponsors who make our work possible.
All right, let's get into it because there are questions flowing in. And I see a shout out to your colleague, Nakita. David is already hammering away at some of them.
She's amazing. Thank you.
Zoe, I know at least one of your questions was answered, but I don't know if you want to start off with the other one.
Which question? I have so many that I want more. It sounds like you have just so many really interesting projects, and it's unique that you focus on existing buildings. So maybe I'll ask, like, I'll back up to one of my first questions, just about how this is possible and scalable. Are there any incentives in the Baltimore area, kind of, or maybe like Retrofit New York, any initiatives, anything that kind of like can boost this, turning these existing buildings that are prevalent and available into affordable, or some affordable, some not affordable places to live, work, be in?
Yeah, absolutely. And so there's different scales of it. So if you have a certified historic building, then you are eligible for funding through the historic tax credits and different grants and things. So there are local in Baltimore City, as well as at the state level and at the federal level. And being in Maryland, we're a little bit spoiled because Maryland is one of the few states where if you go after the historic tax credit and you commit to doing LEED Gold or an equivalent other green rating system, you get an additional 5% in the tax credit as well. And that program is typically more helpful for developers who are doing sometimes a little bit bigger projects, but that's one of the great funding sources. Another one is there is also PACE financing, property assessed clean energy, and that can go with the building and kind of travel with it. So that can work well sometimes for buildings that aren't certified historic structures. And then we're also following very closely a lot of the funding that's coming out through the Inflation Reduction Act, as well as the White House just put out something, and I believe the EPA is putting out something soon. A lot of those legislation and a lot of those will have funding for deep energy retrofits and different types of things that can go into existing buildings. And so there's lots of pockets of funding that are still being, I guess, decided, and they're trying to figure out how to make the money flow. But aside from tax credits, so that's another pocket of money that's coming.
It's a lot of stuff from here and there, so good, good to hear. I think Shannon was next, but not sure if you can talk, Shannon, and perhaps your question was already answered by Dave. But maybe we'll ask the question just in case there's any follow-up, or if Dave wants to answer and unmute. The question was, did the WUFI VTT, which is the mold analysis model, or the generally hydrothermal model, add a requirement for an exterior masonry sealer?
Yes, I can go ahead and answer that in person again. So no, it didn't, because of Baltimore's climate zone, everything was staying as vapor open as we possibly could. So the only additional treatments that we did to any of the existing masonry were tuck pointing, and then interior side lime stucco plaster or fluid applied air barrier, all of it completely vapor open.
Thanks, David. Thank you, and congrats on a great project. Nice presentation.
Awesome. And I think David's question was answered about the windows, both the type and the U value. Thank you, David, for that question, and David Gavin for answering. James Hartford, do you want to unmute and ask your question?
Hi, great projects. I'm curious to know if you did an acoustic study for the recording studio upstairs.
So none of the studios are actually programmed in any way yet. They're sort of left open, and their eventual use will be dependent on whoever ends up leasing those spaces. So it was, right now it's essentially just a wide open shell. If it ends up being a recording studio instead of, say, an artist studio or a sculpture studio or something like that, it would all be retrofit. But I mean, the inherent because it's the third floor addition up there, the inherent qualities of those new construction passive house walls are, they're inherently really good as acoustically.
Do you plan on, or I guess do building owners, occupants plan on leading people through tours there? That could be such a good learning opportunity just like
Yes.
building as a teaching tool. Yeah.
Yeah, and so they already actually have. And so one of the things that Baltimore does every year through the Baltimore Architecture Foundation is something called Doors Open Baltimore. And so this was actually one of the stops on that tour. And so basically Doors Open is a number of sites around the city open their doors, and people can kind of do their own scavenger hunt, if you will, around the city to go and tour whatever sites they're interested in. So Nick and the Midway Cooperative have been great at being able to share and document and let more people into this space to share what they're learning.
That's awesome. All right, up next, I think we have, let's see, I'm behind here. Who just went?
James just went. So
Okay.
Herman had a question about the slab. I was curious too, but Herman, you go first.
Hey, hey everyone. My question is, did this have a slab on grade? Was it a slab on grade foundation and how did you, I guess, improve the slab if you had to?
So we actually had multiple conditions where the existing row houses were. They all originally had dirt basement slabs that were probably only about 5 feet clear. So in that portion of the building, we underpinned and added a completely new, fully insulated basement slab. And then the rear addition is just a slab on an insulated slab on grade. I think we have continuous about R17 underneath both slabs.
Wow, thanks.
And any issues with that process of like excavation? I know Nakita mentioned that it ended up needing an extra layer, well, on the foundation walls of the lime stucco, but any issues like unexpected in terms of existing conditions or like clearance and the kind of equipment that you needed to get in, the material you needed to get in?
Actually, the biggest issues that we had were with city permitting and the definition of underpinning versus curbing. The city doesn't allow curbing, which is essentially insetting the walls in order to go deeper, essentially sort of surcharging diagonally structurally. So that was the biggest challenge in the whole thing. And once we were past that, the actual implementation of it was pretty easy. I mean, it was essentially all had to be hand dug, import the concrete by hand, all that. But they did a great job on it for a small, tight, complicated condition.
Great. And just something to know, underpinning in general is something you have to make sure you're accounting for in the schedule, because it is a relatively slow process. As Dave mentioned, it has to be hand dug. You can only really do 4 feet at a time. So just making sure that you're working with a contractor who's familiar with how to do underpinning correctly to not jeopardize the structural integrity.
All right, great. Next, I think we have Ken Newhauser. Would you like to unmute and ask your question? It's a nice detailed one. I like it.
Okay, sure. And I had to pull up my question and remind myself what it was. But this is another, I guess, a structural related question. So when you're insulating to the inside, did you have to take any special measures to mitigate moisture risks for the beams that are embedded in the masonry? Or did you, maybe your structure took over the load from the masonry, but I'm curious how you handled those embedded beam ends.
So it's interesting because the masonry structure no longer supports any of the horizontal structures of the building. It was determined by our structural engineer that the existing walls actually should not have even been supporting the floors that were originally there. So all of the new floor construction is strictly bearing on the new framed walls that are interior to the masonry walls. So we aren't pocketing beams any longer.
It's an elegant way to sidestep that risk there.
Yeah, I don't know that it was intentional, but that's how it worked out.
Yeah. Thank you.
Awesome. And I think Supriya Mankad was next, but she doesn't have a microphone. And she was asking about potential phasing of the retrofit due to cost constraints. Was there, was There was also another question from David Salmon about the cost per square foot, but if you can talk about costs and phasing, that would be great.
I'll tee it up and then Daisy can add whatever else. I think a big part of the reason why the client was also self-performing was in addition to kind of get the skills, but also to help with costs and have a little bit more control over that process. And David, I don't know if you want to share anything else from the pricing stuff that you were involved with.
I think this project was too small to be phased. We would love to do something that was that large that we could consider phasing as part of the cost strategy for implementing it. And then in terms of, like Nakita, like you said, I think this project is complicated to sort of address cost because the compound was self-performing as the contractor. So sort of figuring out the true cost for a lot of this is difficult. I actually just had a conversation with Nick, the owner, probably a couple of weeks ago, and even he was struggling to sort of get, figure out exactly where he was with it, because not only are they building it themselves, they're also using it as job training opportunities for, local residents, stuff like that, to learn trades and things like that. So there's a lot of components that go into this particular project.
All right, next up we have Mackenzie Stickney. Are you able to unmute and ask your question?
Yeah, hi everybody. I was curious about moisture and drainage. I think so typical with the passive house, you in new construction, you see that air barrier have a drainage plane on the exterior side of that. And looks like you did aerial barrier and then EPS directly on top of it, your furred out wall, and then the vapor barrier. And I guess I'm curious, I think I would anticipate, I'm not familiar with the vapor barrier that you use, so maybe it's open and it's able to dry from the inside if you have like an HRV running. But I'm curious about where your Wolfie said that condensation was happening and how you were mitigating it in a historic building, because that can be really tricky.
So yeah, it was definitely the most complicated design part of this entire project. We had a lot of back and forth with Phius about how we were going to address it. You're right, it's not a cavity wall by any means. In essence, the existing walls are acting like their original mass barrier walls in a lot of way in terms of the bulk moisture mitigation, from rain events and things like that. The interior side vapor retarder is definitely counterintuitive to our climate zone, but it is a smart vapor retarder, so it's closed in the winter and open into summer, so we can help with inward drying and all of that. And in order to prevent any sort of condensation risk within the wall itself, that was one of the major factors that led to our insulation change. Mid-design, we were originally looking at dense packed cellulose throughout the whole thing, and eventually we switched to that EPS continuous between the masonry wall, the new construction wall, and then mineral wool fill.
I guess a follow-up on that, the mineral wool, because it's like hydrophilic and it like distribute the moisture and be able to dry, or was there, instead of like, I guess, why mineral wool from DP cellulose?
Essentially, it's less prone to moisture damage is the primary reason, while still being vapor open to allow that drying to either side.
Great, good question. Next we have David Solomon. Maybe you're, nope, that was different, David. Question was answered. Let's see. Oh, this was the question about cost per square foot. I think, Nakita,
Yeah.
did you address that?
Go ahead, David, are you able to unmute?
Oh yeah, it sounded like David might have already pretty much answered this, but if there's additional detail, it sounds like it was a pretty complicated project to try to get to that sort of simplified number. But even if you have just a ballpark idea, it's always useful. especially these days with just the way construction costs are. And but obviously it's actually a tough question to answer. I get that. I guess I might just add, and it's really interesting to hear about like the insulation changes that occurred. If there are any other kind of lessons learned or things that took the team by surprise through the design or construction process, and and changes that were made, things you would approach differently for the next project as a result of doing this one, that'd be great to hear as well. Thanks.
Yes, I think I gave a pretty long-winded, roundabout non-answer to the cost question because of how complicated it was. I think he put something on the order of he thought Nick that is from the compound thought it ended up probably around 15 or 20% greater than he would have anticipated for, say, a code building. I think a lot of that ended up being those sort of job training components that were into it, the fact that they were self-performing a lot of it, and it taking a much longer time than it otherwise would have if they say they had somebody coming in and doing it themselves. As far as the challenges question, I think that's really interesting. This was actually the first passive house project that we did in-house, so I think there was just a lot of a learning curve that happened there, just sort of running with it and going with it ourselves. The retrofitting of the existing walls was definitely one of the major challenges that comes to mind. I think during construction, the biggest thing that comes to mind for me is sort of being able to visualize the sort of three-dimensional component to a lot of these junctions where the existing building meets the new construction. You can see it clearly enough in drawing a two-dimensional detail, like, oh, that makes sense. I can connect the air barrier easily this way and this way. But once you start to wrap a corner and look at it in all three dimensions, I think there were a couple spots that we had to chase a good bit when we were trying to chase down all of our air sealing and hitting that hitting that air tightness requirement. We spent a good chunk of time working around different parts of the building and trying to figure out where air was going because of that retrofit component to it.
And actually we have in the queue also Brian Scott, who had a very related question. So maybe we can jump to Brian, if you want to unmute, or we can ask. There we go.
Sure. So the question is, if you had to do it again, would you keep any of the existing building? And in the final analysis, what is the value of having kept the masonry shell?
Yeah, I'm so glad you asked that question, and I'll start from like kind of the cultural side and let David get into the technical side. But I think a big value of this was making sure that there wasn't more historic fabric loss in that community. In a city where there's lots of vacants, there are some buildings that get torn down or run down. Being able to show how an existing building can be reused in a way that still kind of keeps the memory of the buildings and of the community intact was something that was really important for both the client's mission and also for the neighborhood cohesiveness. And so, Dave, if you want to get into the technical side of it, I'll tee that up.
Yeah, I mean, Nakita, I'm sure you could speak to the embodied carbon portion of it as well. I know that, even with as much of the building that we demoed, most of it was pretty useless when we got there. A couple of floors were falling into the basement, the roof was leaking and all that. The rear additions were falling off. But even taking that all away, we still saved a solid 50% of the mass of the building by keeping the existing masonry walls, and just the embodied carbon that we were able to save by keeping that made a huge impact. I think if we were to go back and do it again, I would like to do a more thorough embodied carbon analysis just to know exactly how much we used, how much we saved, and things like that. And yeah, keeping the shells, it made it harder, but that's kind of what makes it fun too. It's, everyone's unique.
So Kim, do we have time for one more question before we jump to events?
Yep, go ahead.
Okay, so Peter, I saw you had come on screen. There you are.
Good. Yeah, thanks. No, it's a fantastic retrofit project. It's good. The parapet walls at the top, what condition were they in and how did you treat the tops of them? And related, well, the question about the pocket beams at the upper levels supporting the roof, what conditions did you find them in? How much moisture was there? And you said that you supported it differently. That's a good thing. Carry on.
Yeah, so the parapets caused a number of problems. So I don't know if you saw the one earlier slide where I had the video embedded. That was one of the major early sources that we found of air leakage at the front of the building. There was some cavea essentially stretched for the entire length of all 4 row homes. That air was just leaking straight out of. We had a fog machine in there and it was just blowing straight out. So that took a fair bit of time to tighten up, and that's actually the only remaining parapet condition that truly exists from the original buildings, because the new construction it sets back from the front a couple feet to sort of preserve that existing roof line. But on the sides and rear of the building, the parapet conditions are essentially all gone now because they're embedded within new construction. And then, yeah, the roofs of the existing row homes, they were pretty much totally trashed. Yeah, there was probably years and years of leakage that had been going on in there. And the owner originally actually had intentions of salvaging some of those beams and reusing them for, cutting them down, sawing them down, and using them for other purposes. But in the end, they weren't even able to do that.
Good. So what was the finished roof surface at the end? Yeah, as a previous roofer.
It's all TPO.
Yeah, that's good. Did you check for the moisture content in the brick at the top? In the mortar?
We did not, only because we were not fully engaged during most CA. The contractor was mainly self-performing, but they were working at such a pace that anything would have been able to dry out that was totally soaked at the time.
Very good, thank you. Great project.
Thanks, Peter. Great questions. I'd be remiss if we didn't ask our next gen question to both Nakita and David, if you're both down to answer. And that's, what do you see as the future of Passive House building? Where do we go from here?
Clearly for me, I see it as getting more into the existing building space and blending more of those worlds together. I know Phius is working on kind of the retrofit standard, and that's not going to quite work for some of the historic buildings that have to kind of not be overclad, but really working through more of these projects and figuring out how to make the existing buildings still somewhat look the same on the outside, but still perform the way they need to perform on the inside.
Yeah, I think being a little more than a month out from PhiusCon, I think it's really encouraging to see all the changes they're making on the policy side of things. What's being done in states like Massachusetts and stuff like that. The amount that it's growing and the speed with which it's growing is really exciting. I think what I would like to see moving forward is it continuing to expand to different building types and things like that. I'm a big, a lot of my work is retrofit, so I love working in that space. Larger retrofits, commercial projects, expanding into different multifamily light tech housing, etc. I mean, I want it all, really.
Both of you, how close are we to having a strategy that we can share for every single existing building type?
Closer than we were. I'll leave it there.
I mean, that's the fun of existing buildings, is I don't think there is a one set way of doing it. Everyone is unique. And so the sort of discovery that goes along with that is what makes it fun.
Yeah, it's tough and it has to be addressed individually, but also, all of these lessons learned and pictures and strategies that you're sharing are so important, so that we can all, learn from exactly what you've done and not make the same mistakes and have the same successes that you've already had. So that's why we're here.
Thanks so much for joining the last Passive House Live Next Gen series of 2023. We hope to see you next month. We'll have Elizabeth Badadan of Carbon Wise, based out of BC. Until then, very happy holidays. And again, thank you so much to Nakita Reed and to David for giving us all this learning and invaluable inspiration. Thanks.
Thanks, y'all.
Thank you so much.